Hello everyone, welcome back to my YouTube channel Science Math Tech. And today we all will be discussing about basics of machine learning. What is machine learning? Different types of it. Then what are the steps which we'll follow while performing the machine learning? And what are some applications in real life? Okay, so let's move on. So these are the different types of machine learning. Initially, machine learning is divided in three types. That is supervised, unsupervised, and reinforcement. Now, supervised has two types of models, that is the regression model and the classification model. The point is supervised models have something called as features and labels. Okay, so that when you have your output data, you already know what kind of data it is or what is its data type exactly. Or if I give you an example, imagine you are predicting the cost of a house, okay, based on its area, the locality where it is located, and many other factors. So now, depending on it, you know that your final output is the price of the house. You know your final output and also the features which you are considering for the output. So hence it is supervised, where you know everything. Then comes the unsupervised, where the example is clustering. In unsupervised, you don't know what your exact output is. You just basically, cluster or group everything based on some common features or factors. Okay, we'll discuss about it. And then the third part is the reinforcement. Okay, so let's move on and let's see what exactly supervised learning does. And as I said in this slide, supervised learning has two types, the regression and classification. Now, the regression model, what it exactly does is it is used for predicting numerical data. Okay, like I took the example of pricing of a house. So here we got the price, a numeric data, right? So we can represent it easily in terms of graphs, okay, numerics. And we can take n number of examples, like considering predicting the temperature of a certain locality after a few days or a few months, depending on the climatic changes happening. Okay, this can also be an example in a regression. And there are many types of regression models as well, like linear regression or multi-linear regression model. Then we also have another type, which is the classification one. Now, what classification does is it basically groups the items based on the outputs which we get. Like for example, there can be a binary classification, which is nothing but if you have a data which can either be answered as yes or no, or it can be true or false. So this is binary classification. We get two types. Then also comes the multi-classification model, where what we do is there can be multiple classifications in the model. Like since we had two in binary, here we can have multiple classifications. Okay, but we know that what is our final output. Hence, it comes under supervised. Okay, and I talked about two terms, which is features and label. So features are basically the data which we took to predict something. Okay, that is our input, and the one which we get as the output is called as the label. Okay, let's move on to the next one, which is unsupervised learning. Now, in unsupervised learning, as I told, that we do not know what are the, what can be the label or what exactly should be the output. We basically group them or cluster them, since clustering is the type. So we basically group and cluster them according to some, similar characteristics. Okay, so like take an example of this graph given here. So assume this can be any data, like here it is height of the ground and the width of the ground truth. Now, as per that, the plot is been scattered, and it's imagined that the area which is above, up till a certain area, that can be considered as a separate thing. Then the one below it another, then below it another. Accordingly, it has been colored and segregated based on some characteristics. Similarly, if you consider this example, where there are multiple people and they have been categorized into three groups. Okay. Imagine we have been given groups such as we have been given birds. Example. Let's consider the example of birds. Okay. So in birds, it has been told to classify them according to features like we want. Okay. Then we classify maybe into two groups. One, the birds which have wings and can fly. One which have wings but cannot fly. Like the one which cannot fly can be penguins or ostrich. The one which can fly can be sparrow, crow, anything. Okay. So what we did here, we did not know what the output was, but we divided them based on their characteristics. So this is unsupervised learning. Okay. Then comes our third type, which is the reinforcement learning. Here, what exactly happens is the agent or the model, machine learning model which is present, it learns from the actions which are being performed between us, and it grows based on some rewards or you can also call it as a reward oriented approach. Okay. And what's the reward for the agent? That it learns and becomes more better. Okay. It learns from the actions, the observations from the environment. That is what we are providing it, and it improves. The best example for the reinforcement learning model is nothing but our own chat GPT, which we use in our day-to-day life. Okay. Like, see, earlier the chat GPT model, which you all know, GPT-3, that was not much good or better in answering our questions or giving proper responses. But consider now the ChatGPT 4. It can even provide you images, better responses, and good updates. Right? It's been a better updated model compared to GPT-3. So what happened is throughout the responses which have been provided from the user, it improved itself. Okay, so this is reinforcement learning, learning from our own mistakes and growing. Okay, this is the reinforcement learning. Now, I'll tell you various steps which are involved in the machine learning process which we follow. First one is the data collection. Uh, Imagine like the model which you are taking as a small child. Okay, initially the child knows nothing. You have to teach him everything. Now, for that, you need a data set. You need to know what you have to teach him, right? So, first we need is the data. So, first step comes is the data collection. Okay. Then the next step is data cleaning. Imagine that if you have a data and sometimes there are chances that there are null values in it. Like imagine we are taking data of a locality where what do people do, and does any of the members in their family belong to military, or they have performed any military operations or police or any civil services. Okay, there can be few families which will obviously have some output. Okay, but there can be many families where the output is null since there is no member from them which has went into civil services. Yes. So there can be multiple, there can also be chances that the field, output field or input field we have been provided can have multiple values for one identity, one key, but can have a single value for another key. So like this, the data is not filtered properly. So before feeding it to the model, we should clean it, we should cleanse it properly, filter it, and then only provide it to our data model. Okay, this is the second step. Now, the third step is nothing but feature engineering. Now, what exactly happens is we can have n number of inputs. Okay, we can have n number of columns as an input, but only specific columns are required for getting the output. Okay, let's consider our previous basic example, that is pricing the house based on several characteristics. Now, we can have a number of data like for example, area of the house, the locality. We can also have the paint of the door. Let's consider anything, paint of the door, or a number of washrooms or number of rooms in it, anything. Now, to predict the pricing of the house, we do not require the fields like color of the door. What will that do, right? It's a useless data. It was just in the data set, but we don't need it, right? So here comes the feature engineering, where we select specific features for providing our output. Okay. Then comes the data splitting part. Now we have identified the specific features. Okay. Now we divide our data into two parts. One is used for training the model, and another is used for testing the model. Okay. So generally the data can be split into 80-20. That is 80% of the data for training, 20% for training. This may vary depending on the user, what you want to choose. But on a general basis, 80-20 is considered a better dividing ratio. Okay. So now the model will be trained on the 80% data, and the 20% will be split for the testing purposes, which will be used after the training happens. Then comes the model selection. Now we have split the data, right? But there are several models which you can use. Like I said, in in the regression one, we had linear regression, we have multi-regression model, In classification, we also have binary and multi classification model. Similarly, we have many models like decision trees or random forest. Okay, from that, we have to choose the specific model which we require for our purpose. Okay, so next time comes is selecting the specific and required model. Then comes the model training. Okay, model is selected. We have our specific features. We have split the data. Now we'll train the model on the training data which we have selected. Then comes the model evaluation and optimization. Like after the training, we'll evaluate whether the model is giving us right outputs based on the testing data which we have split earlier. Okay, the 20% data which we had split. We'll give the inputs from that and match them with the outputs which we already have with us. Okay, that will give us the accuracy and the error which is there in our output. According to that, we can optimize our model by even changing the model as well. We can even go for another model if we do not get the better accuracy, or we can change some metrics in it. We can get some new features, change them, and we can even change the data which is split because we randomly split the data. This is the most important thing. We do not select that we'll take the first 80% or the last 80%. We randomly pick up 80% data. Okay. And I also said this number can vary. You can even take 70% to train or 60%, 50%, anything. It's on you. But the training data and split data is different. Okay. We can take it randomly. Okay. So we can even change that, optimize our model. Okay. Then the next step comes is model deployment. Once we have checked everything, whether the model predicts it properly, the accuracy is good, then we deploy the model officially in real life. Okay. And the last step comes is maintenance and monitoring. As we all know, we have deployed everything. We have done each and every step. Now we also have to maintain it, right? And also monitor whether it is performing right on certain specific conditions or not. Okay. Like imagine there is no maintenance. Okay. If we deploy a model and it is like that forever and ever, for years, it is still going. Imagine we were still using GPT-3. Okay. Even though GPT-4 was the necessity because there was no maintenance. There was no monitoring whether it is still performing good or we need to improve or not. Okay, so that's the important part. After everything, maintenance and monitoring is most important. Now, I'll tell you some of the applications of machine learning which can, help increase your curiosity in learning it. Okay, first one is the computer vision. Now, you all know that we use our phone to capture the images. And one more important thing is in Google Photos. Okay, there is an option where it already segregates the photos based on the based on the person which is there in the photo. Like it tells you there are several fields in it, and it tells you what like who is this person in that particular field. All the photos are there where that person appeared. Okay. Even some of the phones have this inbuilt feature in their gallery or the albums as well. Okay. So this is nothing but segregating based on the person. This is nothing but object detection. See, here the dog and cat, they have been distinguished separately. Okay. Then another one comes is classification and localization. That is where exactly the object is. Now you told the machine that this is a particular object. Like if I tell him this is a flower, a particular flower, okay, sunflower, we'll guess. Then I take a random photograph of a field where there are many flowers, including sunflowers. Then the machine or the model has to tell me that this is sunflower. It should particularly identify that. Okay, this is the classification and the localization problem. Then comes the image classification. That is, I can provide it n number of images, and it has to tell me perfectly whether it is the particular image which I want or not. If, for example, I need to identify wild animals. Okay, I have trained my model entirely on many images of wild animals. Okay, and I give it image of a cat as it is given here. Now it has to tell me whether it is a wild animal or not. Okay, if it tells me that cat is a wild animal, then our model has failed. We should obviously go for either another model, we should test it again, and we should improvise. Okay, but if it identifies properly that no, cat is not a wild animal, if the next time I give it a hyena or lion and it said yes, it is a wild animal, then our model is working fine. Okay, so these things can be done: the object detection, the localization classification, and the image classification. Okay, Then comes natural language processing, NLP. This is one of the major booming fields right now. The first one you can see here is identifying the text or extracting the text from an image. Okay, we all must have used the Google's camera, right? Google Lens, we say. So we can just click a photo, it extracts all the text. We can just copy it, paste it somewhere, and use it as per our purpose, right? So see, this is the best example of NLP, extracting text. From that, we can also get information, such as anything, any important field we want. For example, if you are scanning a bill, okay, then we can train our model to always take the price from it, okay, or calculate the price according to the things which we have ordered. Okay, this can be done based on the text extraction. Okay, second thing comes is the sentiment analysis. That is based on a particular sentence to identify whether a person is currently happy right now, sad, angry. We can detect the mood of it. Like in this image, it may not be properly visible, but based on this text, the right side it identifies whether it is a physical discomfort or the emotions, or he's on the work or something else, right? Similarly, we can identify whether a person is angry, happy, sad, or anything. Okay, sentiment analysis, important part. Then there are also two other features which we are well known of. Okay, first is a text to speech. You know, sometimes when you Google an information, okay, and when the page loads, Google automatically starts to say what is written on the screen. Okay, so that is the text to speech. Okay, very useful feature. And the last one, from many features of NLP, this is one of the thing, that is speech to text. Okay, most of the times we are busy doing something, but we need to respond to a particular person, right? In that case, what we do, we just simply click on the mic option which is available. We speak what we want to type. It automatically types it, and we just click on send. Done. That is speech to text. So these are the four main features of NLP, the natural language processing. Okay. Then comes generative AI. Now all the things AI available, such as ChatGPT, Gemini, or Copilot, all these things come under the generative AI part. Okay, so generative AI, what it does is it has been trained to think like a human, so that it generates proper outputs similar to what a human can do. Okay, and other things such as the chatbots we create for any projects or something, those also come under generative AI. Okay, not only this higher level versions, but even the small chatbots can also be considered. Okay, so that is generative AI, which helps us to generate any kind of text or even images, videos, which currently ChatGPT and higher versions of AI are capable of doing. Right? So this can be done in generative AI. There are many other functionalities of machine learning, but these three are the I can say major one, or used maximum times. Okay. So now I guess with that said, most of you must have got the idea what exactly machine learning is, different types of machine learning, the steps which we follow in machine learning, and what are a few of the applications of machine learning which we use in real life. Okay, so now with that said, I'll end my video here. So thank you all for watching the video. Please like, share, and subscribe. And I'll tell you, I am going to make some better videos in the future with the best content I can provide you. I know this was a very basic video, which mostly had nothing, I can say. But this was the intro, right? I can even go further, extend it to give you better knowledge of everything. Just write down in the comments what kind of video you would like to enjoy based on all the videos which I had previously. Like I made videos on the projects of SQL, even the theory of computation, then this one, machine learning. So based on all this, you can ask me for any kind of video if you want. I'll surely look into it and we'll meet next time. So thank you everyone, and please subscribe to our channel, like the video and share it. Thank you everyone.